Hi class, this is Mrs. Lyons. This video is on molar mass, which is defined as the mass of 1 mole of any substance. Okay, so before we start talking about molar mass, I just want to give you a practical example, something that you can wrap your head around. So tell me, what is a dozen? Hopefully, you said that was easy. A dozen is 12. Okay, so if I have 1 dozen eggs, I have how many eggs? 12. If I have a dozen feathers, how many feathers do I have? If I have a dozen bricks, how many bricks do I have? Okay, the point is, if I say to you, I have a dozen of something, you automatically know, because you've grown up knowing what a dozen is, you know I'm talking about the number 12. Now here's the other thing I want you to think about, just kind of stretch your mind a little bit before we get into this whole concept of the mole. If I had a dozen eggs, a dozen feathers, and a dozen bricks, would they all have the same weight? Hopefully, you said no, they wouldn't. Feathers would be much lighter than eggs, and eggs would be lighter than bricks. Okay, so each one of those things would have their own specific mass if I were to weigh them. Now we get into how this applies to us. How many is a mole? And I want you to get this in your head so that a mole is no different than a dozen. If somebody says to you, how many something in a mole, you're going to spit out this number. This number is 6.02 times 10 to the 23rd. It's called Avogadro's number. Okay, so if I say I have a mole of donuts, I have 6.02 times 10 to the 23rd donuts. If I have a mole of atoms, I have 6.02 times 10 to the 23rd atoms. If I have a mole of molecules, okay, so compounds that are bonded together, so let's say carbon dioxide molecules, I have 6.02 times 10 to the 23rd molecules. Okay, so you get the idea. If I have a mole of anything, a mole, just like a dozen is 12, a mole is 6.02 times 10 to the 23rd. Now, just like a dozen, does a mole of everything have the same mass? Absolutely not. And this is why we get into the molar mass. The molar mass is the mass or weight of 1 mole of any substance. Now, if you think about that, think about having a mole of marbles. Okay, that's a lot of marbles. And that, if you could weigh it, would have a huge, enormous mass. Okay, but then think about an atom and having a mole of atoms. Atoms are so tiny, you could hold a mole of atoms in the palm of your hand. Okay, so the mass of a mole of atoms is very, very small compared to the mass of anything that we could pick up around us and have in our daily lives. So we want to know, how do you calculate the molar mass of something? I'm going to go back here for just a minute. If we want to look at a mole of a compound or an element, we are going to refer to our periodic table. And if you recall, each square on the periodic table has an atomic number, an element symbol, and then there's a decimal number down at the bottom. So your periodic table for carbon, the 6 is the atomic number. C is the symbol for carbon. 12.01 is the molar mass of carbon. That means that if I had 1 mole of carbon atoms, means if I had 6.02 times 10 to the 23rd carbon atoms, it would have a mass of 12.01 grams. Okay, so now we're going to do some calculations. Okay, and we're going to use our periodic tables. So the molar mass of carbon dioxide, CO2, we got to count up our atoms. We have one carbon atom. We have two oxygen atoms. Okay, so we got to look at our periodic table. Carbon has a mass, if you look it up, of 12.01. Oxygen has a mass of 16.00. Okay, we just need to add up all of the masses of everything that make up this carbon dioxide molecule. So we have one carbon, two oxygen, so we're going to add 12.01 plus 16.00. That gives us 28.01. Our units here are going to be grams over moles. What that means is it's 28.01 grams is 1 mole of carbon dioxide. Let's do another example. Aluminum chloride. All right. Now again, we have to count up our atoms. We have one aluminum. We have 3 chlorine. Aluminum has a mass of 26.98. Chlorine has a mass of 35.45. So I'm going to add these up. 26.98. And I need to do a little math on my calculator. I'm going to take 35.45 times 3, and I get 106.35. And I'm going to add that with 26.98. I get 133.33, my units, grams per mole. All right, one more example. Last example, the molar mass of barium nitrate. The reason we do this example is sometimes people get confused about counting atoms when we have parentheses. So let's count this up. We have one barium. We have, how many nitrogen do we have? Okay, and here's where you've got to remember this parentheses, this 2 applies to everything within the parentheses. So this is like saying there's one nitrogen times 2. So we have 2 nitrogen atoms. And then we have 6 oxygen atoms. So I need the mass of barium, which is 137.33. The mass of nitrogen from my periodic table is 14.01. The mass of oxygen is 16. So I'm going to do my math. I've got 137.33 plus 28.02 plus 6 times 16. That one I need my calculator for. 6 times 16 is 96. I'm going to add these all together. And what I'm going to get is 96 plus 28.02 plus 137.33. I get 261.35 grams per moles. All right, so that is how I calculate the molar mass of barium nitrate. Okay, so we will have some more practice of this, but this is a pretty straightforward thing to do. Hope that helps. See you soon.